Good day, viewers. This evening we shall be solving questions involving specific heat capacity. Now, in order to solve this type of question, we are going to make use of a principle called principle of mixture. Now, principle of mixture states that the total heat lost by hot substances is equal to the total heat gained by cold substances, provided no heat is lost to the surrounding. So according to this question, a copper ball was at a very high temperature of 950 degrees Celsius. It was transferred into a vessel that contained water. So definitely it has to lose heat. Then that vessel will gain heat. The water inside it will also gain heat. But according to this question, we have to neglect the heat gained by that vessel. We have to ignore it. So now let's get it started. So heat lost by copper. Heat lost by copper is calculated as the mass of copper times the specific heat capacity of copper times change in temperature. Now for the mass of copper, 300 grams, we have to change it to kilograms because the specific heat capacity is in kilograms. So 300 divided by 1000, so that one will give us 0.3 kilograms. Then times the specific heat capacity of copper is 400. Then change in temperature now is from 950, the final temperature is now found to be 100. So the change in temperature is 950 minus 100. And that is 0.3 times 400 times 850. So let me quickly do the calculation. 0.3 times 400 times 850. So this is equal to 102,000. 102,000. So 102,000 joule, since the unit of heat is joule. Now that is heat lost by copper. Now the water inside this vessel will gain heat in two ways. Now let's find the first way. Heat gained by water. Heat gained by water. When its temperature rises from the original temperature of water was at 25 degrees, then till the final temperature is 100. So when the temperature rises from 25 degrees Celsius to 100 degrees Celsius, so the heat gain here is also mass of water times specific heat capacity of water times change in temperature. Now for the water, the mass is, we don't know the mass of water here, so we want to write it as M. So that is M times, and the specific heat capacity, the mass of water here is 250 degrees. So we have to divide that by 1000. 250 divided by 1000, that is 0.25. So 0.25 times the specific heat capacity of water is 4200 times the change in temperature from 25 to final temperature 100. That is 100 minus 25. Then this is equal to 0.25 times 4200 times 75. And let's quickly do this calculation. 0.25 times 4200 times 75. This is 78,750. 78,750 joule. Then again, the question says that calculate the mass of water that will boil away. So that means heat is also gained for the mass of this water, or for this water to boil away. And and that one is going to be calculated as the mass of water that boils away times the specific latent heat of vaporization of steam. Now, I want to write that as heat gained by water, heat gained by water in boiling away. And that will be taken as mass of water that boils away times the specific latent heat of water. So that mass of water that boils away, we don't know it. Then the specific latent heat of vaporization of steam is found to be 226,000. That's 2.26 times 10 raised to power 6. And this gives us 226,000 M. So now, if you apply the principle of mixture, the total heat gain is equal to the total heat lost. So the total heat gain is 78,750 plus 226,000 M is equal to the total heat loss, and that is 102,000. So therefore, we want to collect like terms. 226,000 M is equal to 102,000 minus 78,750. So let's quickly do this calculation. 102,000 102,000 minus 78,750. So that is 23,250. So we have 2,260,000 M is equal to 23,250. Now we want to divide both sides by this 2,260,000. So M now is equal to 23,250 all over 2,260,000. So the mass of water that we boil away is, let's do the calculation, 23250 divided by 226,000, and that is equal to 0.01028 approximately. Then kilograms, 0.010288 kilograms. So if you want to change this to grams, you have to multiply it by 1,000, and that will give us 1, 2, 3, and that is equal to 10.3 kilograms. And this is the mass of water that we boil away. Thanks so much for your time and attention. Please don't forget to share this video. Don't forget to like, comment, and share. Thank you.